talking about entropy in a chemical reaction. So how will it look like? So what do we talk about? We say if a number of like the number of gaseous molecules in a reaction changes, means either it's gaseous reaction that is happening, or maybe a compound is broken down into gas molecules. So if a number of gaseous molecules in a reaction changes, there will be a change of entropy. And in this condition is that if greater the number of gas molecules, greater the number of ways of arranging them, greater entropy. As we discussed in the decomposition of CaCO3 as well, and another very major reason of why entropy increases in this reaction because a gas molecule is being produced. Walaikum assalam, everyone. अच्छा, इस केस के अंदर particularly in this reaction, which reaction I'm talking about the decomposition of CaCO3. We say that the entropy is increasing, and the very major reason why entropy is increasing because the gas molecule is being produced. Let me know when you're done writing with this so that I can change the slide. It's another topic. Let's talk about another reaction. As far as this reaction is concerned, N2 plus 3H2, and this is changing into what? It is changing into 2NH3. Let me tell you again, in this reaction, as I said, that we say that the entropy increases when it comes to this reaction. Why? Because the gas is produced as a product. ठीक है, यहाँ पे इसलिए हम एंट्रोपी इंक्रीज करने की बात करते हैं. सो कंपैरेटिवली अगर हम इस इक्वेशन की बात करें, so इस इक्वेशन में तो रिएक्टेंट्स में भी गैसेस हैं और प्रोडक्ट्स के अंदर भी गैसेस हैं. So how will you conclude if you have been asked that entropy is in this particular reaction increasing or it is decreasing? So what would be your reaction in this? What will be your reaction? How will you calculate the entropy? Excellent, Abdullah. You will see the moles of the gases. If we say, if we see over here, in this case, we have 4 moles of the gases, 3 of hydrogen and 1 of nitrogen. And after the reaction, there are 2 moles of the gases, which is ammonia. So what do you think? Entropy of the system is decreasing and increasing? When the moles decrease, होने का मतलब ये है that the number of molecules are decreasing. Okay. So when the number of molecules are decreasing, automatically this will cause decrease in entropy. Huh? And why it's decrease in entropy? Because the system will become more ordered. Because of the fewer number of molecules. System will become more ordered or organized. Or we can also make a statement, and that statement is that reactants N2 and H2, they are energetically more stable than the products NH3. I hope it's okay now. Okay. Now moving ahead, next part is the calculation. How do we calculate entropy changes? How do we calculate it? We say there is an equation that says S is basically the symbol through which you say that entropy is changing. So entropy of the system, standard entropy of the system will be this. Entropy of the products entropy of the reactants. Sum of the entropy of the products and sum of the entropy of the reactants. उन दोनों का जब हम difference निकालेंगे, so we can have the change in the entropy of the system. ये ऐसे बनाया जाता है, something like this. This is called sum of all. Yeah. This sign is something like this, and this is called as what? Sum of all. So if you get the sum of products, sum of entropy of the products and sum of the entropy of the reactants, and you subtract them, and then you will be getting the entropy of the system. Let's suppose if I have to calculate the entropy of what? If I have to calculate the entropy of the same thing, N2, the formation of ammonium, and then it will be 2NH3. तो अगर मुझे ये कोई कहता है कि entropy का change निकाले, so how I'm going to calculate the change? Is equals to, पहले हम product का लेंगे, product के साथ क्या लगा हुआ है? 2 लगा हुआ है. So that means 2 multiplied by entropy of ammonium minus entropy of nitrogen, which is a product over here, plus 3 multiplied by entropy of hydrogen. That's how you will calculate it. Are we done? So I'm giving you a question to solve. Just solve it and calculate the entropy, and I hope that the answer is going to be correct. So the question is calculate entropy change of the system, and the equation is magnesium plus oxygen. If equation is somehow not balanced, please do check that equation is required to be balanced or not. So what will be the change in the entropy? Calculate it and share the answer with me. So the correct answer to this question is 193 minus 193.8 joule per mole Kelvin. Done? Okay, so the next topic is Gibbs free energy. Now, अगर हमें reaction की feasibility check करनी होती है ना, whether the reaction is feasible or not, reaction is possible or not. So this feasibility is dependent on two things. One, the feasibility is dependent on the entropy of the system, because entropy tells us that whether the reactants are energetically stable or they are not stable, and it also depends on the Gibbs free energy. So we cannot rely on one of them. We cannot say that entropy से हमें पता चल सकता है only that the reaction is feasible, the reaction is possible. ना हम सिर्फ और सिर्फ इस बात पे डिपेंड कर सकते हैं कि गिब्स फ्री एनर्जी से हमें पता चल सकता है that the reaction is possible. If we want to see that whether the reaction is feasible or not, we need to see both the things. We need to see entropy of the system. We need to see Gibbs free energy of the system as well. So then we need to understand what Gibbs free energy is. So Gibbs free energy is basically what it is, the energy change that takes into account both the entropy change and enthalpy change of the system. So I repeat, what Gibbs free energies talk about? Gibbs free energies talk about were two things, and what those two things are, the two things, it talks about the enthalpy change of the system and entropy change of the system. So what can we say? What Gibbs free energy is? I mean, what can be the equation of this?
G equals 3 delta.
If I have to do it or I have to write the equation, so delta G with standardization supposed to be mentioned is this. Enthalpy change of the reaction subtracting with the entropy change and temperature needs to be there. Here delta G इसका यूनिट आप क्या लोगे? इसका यूनिट होगा किलो जूल पर मोल और इसका यूनिट क्या होगा? इसका यूनिट होगा किलो जूल पर मोल अगेन. टेम्परेचर का अगर आपने यूनिट लिखना है मैं इनकी यूनिट नीचे लिख देती हूँ, इज बेटर. और अगर हम एंथैल्पी चेंज की बात करते हैं, एंथैल्पी चेंज का यूनिट क्या होगा? किलो जूल पर मोल. टेम्परेचर का यूनिट क्या होगा? इट्स केल्विन. एंड एज फार एज एंट्रोपी चेंज इज कंसर्न, एंट्रोपी चेंज का यूनिट होगा जूल पर केल्विन मोल. All of them are in kilojoules. So do you think that it can remain in joule per Kelvin mole? No, it needs to be calculated in kilojoule per Kelvin mole. Or how can you do it? You can do it by dividing it by 1000. Are we clear? Are we done writing it? Shall I move on? Okay. So the next part is the calculation. अच्छा, this particular equation जो हमने अभी यहाँ पे लिखी हुई है, this equation can change into this as well. Let's suppose कि अगर आपको temperature calculate करना हो, so this equation can be changed like this too. I hope you know that. I hope you can do that as well. But just for the sake of my clarity, मैं आपको ये बात बता रही हूँ. The both are the same equations. If you are calculating the Gibbs free energy, then you are going to use this equation. If you are calculating the temperature, then you're going to use this equation. So let's suppose the question is calculate Gibbs free energy for the reaction of maybe methanol with hydrogen bromide at 298 Kelvin. Delta H for this is minus 47 kilojoule per mole. Entropy change for methanol would be 240. Entropy change for HBr would be 99.0. Entropy change for H2O would be 70.0. Entropy change for methyl bromide would be 246. So आपको सबसे पहले तो सिस्टम की एंट्रोपी निकालनी होगी बाय द प्रीवियस इक्वेशन ऑफ एंट्रोपी जो आप लोग ऑलरेडी इस्तेमाल कर चुके हो. फिर जो भी यहाँ पे आंसर आएगा उसे आप किलो जूल के अंदर कन्वर्ट करेंगे. फिर किलो जूल में कन्वर्ट करने के बाद आप उसको कौन सी इक्वेशन में रखोगे? गिब्स फ्री इक्वेशन में रखोगे एंड देन यू विल हैव द फाइनल आंसर. सो इट नीड्स अ लॉट ऑफ वर्क. So please quickly calculate the answer for me. Yeah, that's right. The answer to this question is minus 40.1 kilojoule per mole. Okay. So how do we get to know the feasibility of the reaction? Sorry? अगर delta G negative हो तो the reaction is feasible or not feasible? If the delta G's value is negative, the reaction is feasible. It is possible to happen. Remember this. If delta G is positive, there can be two possibilities. Either it is positive or either it is negative. So if the delta G is negative, then we would say that the reaction is feasible. And if the reaction is positive, then the reaction is not feasible. There are two possibilities. So I'm giving you a quick, again, a question. And right now, after that, you will tell me that whether the reaction is, this particular reaction is possible or not. So 2Ca plus O2 and changing into what? 2CaO. Here the value of delta H is minus 635.5 kilojoule per mole. Entropy change for calcium is equals to 41.00 joule per mole Kelvin, or for oxygen would be 205.0. And the entropy change for calcium oxide is 40.00 joule per Kelvin mole. So calculate the Gibbs free energy and also calculate that whether the reaction is feasible or not.